This is Algebra 1, Semester 1, and it's the third unit called Graphing Linears, and linears is another name for lines. It's the fifth lesson called Domain and Range Practice. It's on CreatorMathcom under the Algebra 1 tab, and you may have to Google CreatorMath.weebly.com to find the website. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. Before we get to the actual problems, let's go ahead and look at where to find the notes. That can be a little bit difficult for students. So here's the actual website name. It's CreatorMath.weebly.com. If you Google that, hopefully you can get to this homepage. Looks like this. Any questions on the comp book, you guys? I always have students that are asking questions about the comp book. They're not sure of certain things. Scroll down on this homepage, find the words composition book, and follow all the directions, watch all the videos, and adhere to all the turn-in dates. Put things where they belong, and take the notes in the comp book, and you should have a 90 to 100% on the composition book. Now, when it comes to the notes, you have to go to the tab of the class you're in. For this video, this is the class, for this class right here, it's the video we're making. So under this tab is where you'll find four things. You'll find the vocabulary, you'll find the lesson videos, you'll find the problem sets, which we'll go over here in a minute, one of those, and you'll find the actual notes. So just to model for you where those notes are, first things first, we need to find the semester we're in for this particular video lesson. It's this one here. Here's the table of contents. You should have copied every single line of this table of contents onto pages 2 through 6 of your comp book. If not, please stop what you're doing right now and go ahead and do that. That's really important because that helps you place notes and everything in the right place according to what page numbers are laid out. So now we're going to find the unit that we're looking at. So we go down to the unit here, Graphing Linears, and these are all lessons. Each one of these is a lesson. We're down on lesson number 5 for this video. It's Domain and Range. Here are the pages in the comp book upon which these notes should go, and please don't take this video's word for it, but go back and look at the original table of contents at the time you're viewing this video. It is highly likely these page numbers will have changed. So notes go here, the problem set is here, and the video solution that we're doing right now will go right into this link, okay? So if we click notes that go on these pages in your comp book, sometimes I have to open it a couple times. Sometimes you get a picture of the board, and sometimes you get a picture of my notes. Now, see how this one remains blurry? So we're going to go back and reload it a second time. For me, if I've loaded it twice, it always loads knock on wood. Let's see if it holds true or not. There you go. See how it brightened up? And now we can go ahead and enlarge these notes, and we can copy these. You can copy these into your comp book on the correct pages, which we just discussed. So this is on domain and range. Domain are the x values and range are y values, and that while that's very simple on its face, then the words domain and range I have found for students are somewhat cumbersome. I just think it's the complication of the word domain and range. They just don't really click in students' brains. So when you see what they are, you're going to be like, oh yeah, those are simple. If I could just remember that they're the x values and the y values, this would get a lot simpler. So somehow the names make it sound harder than it really is. The refresher here is x is the input or independent variable, and y is the output or dependent variable. And I'll go over that about 3 more times because that's kind of lost on students too. And let's see, domain is the name for the set of x values, range is the name for the set of y values. The function uses a model. The model is either a factory or something that goes to work on a tool or something that goes to work on inputs. So here are the input values, the domain. We put an x into this factory and we get out a y. That's why x is called independent, because we can pick anything we want. The y is dependent because it spits out based upon how the function works on it. So this one is independent because we get to choose it. The y is dependent because it depends on what the function does to it and is therefore dependent on what this factory does to it. So we have a couple of different ways of representing this. A table is very common. You'll see that in some of the practice problems we do. We have a list of the x values. This would be the domain, and this would be the range, because domain is the x values and range are the y values. So We then have the function that works on these that takes everything from this 0 to 0, this 1 to 3. This is an independent variable because we input it. This is a dependent variable because we output it, right? It gets delivered based upon whatever this function is. In this case, the function is being multiplied by whatever we input as an x, being multiplied by 3, and then that would be our output. So somehow very simple and somehow very complex at the same time. Students can really get this easily. Some of the parts, they're like, oh, this is so easy. And then another time you ask them and their eyes glaze over and they go, I have no idea what you're talking about. All right, so put these problems into your notes. And let's go ahead and look at the problem set. And we'll talk about some of these concepts a few more times. All right, so what is the basic understanding of domain in algebra? Well, the domain is the set of x values, right? So we input x's, just like in that factory model there. There was a factory. We put in x's and we get out y's, and the factory does something to them. All right, and that's the factory is another term for the function. What's the basic understanding of a range? So the range are the output values that's spit out, so it's the set of all y values. And when we plot a point, we'll see this in a minute too, we use x comma y. Just go in alphabetical order, you guys. The x's go in first and the y's get spit out. So we put in x's and out spits a y. This one's independent because we get to choose it. This one's dependent because it depends on what happens in the factory as to what it is now, what it now becomes. So let's see, number 3. Why are the x values the independent? So, we often have we live with our parents, or we are students, or whatever. We often are not independent yet. When we move out of the house, right, and leave our parents, now we become independent. We get to do what we want. So the x values get to do what they want. They're independent. And it's because they are the input values. So because they're the things going into the mix, we get to choose them. They're independent. They get to choose for themselves. But these people over here, they haven't outgrown the house yet. They are still under the, the roof of their parent or guardian or what have you. And now, so they depend on what happens in the factory here or home. And that's what is, so they're dependents, right? If you're thinking of that term, the way it's used in culturally in our society. So why are the y values dependent? Because they are produced from the input x values. So because they are produced, they are dependent on what the x values are. Right? So the independents get put in and the dependents get spit out. What is a common model to explain a function? We like the factory, right? The factory is a function. We input an x and it outputs a y. The x's go in, the y's come out, and this factory works on it. Sometimes they'll show it with gears in here, right? There's gears going on and there's levers and things are working on this x value. And just say it's 3 times, right, x. Right? So x is a 1, that's the input. 3 times 1 is 3, and now it outputs a 3. So it's really pretty simple. Sometimes I feel like we make this more complicated than we need to, but nonetheless, that's what it is. So a factory or machine upon which the independent x input values are worked on, and the dependent y output, there we go, and the dependent y output values are produced from. Okay, sorry for some dangling prepositions there, but that's the way it explains easiest in my mind. All right, what are the tools we use to illustrate the effect of a function, to illustrate the effect a function has on the input values? More than one answer may apply. A chart or table, so we use a chart or table like this, right? We put x and y, and then we list them here. Those are all the domain. And we list all the outputs here based upon what the function does in between here. If it's 3 times x, right, you put a 1 here. 1 times 3 is 3. It spits out here. So a chart and a graph. The graph is the other thing. If we go here and we put in a 1, so we're here 1 on the x, and then it's y, then you go 1, 2, 3 on the y. You go up to here, put a point. 1, comma 3 becomes this output point. All right, so, and then we do a couple. If this was 2 and this was 6, you'd have 2 and 6 would be up here, draw a line, and the graph now represents the how this function is working on the input x's and the output y's. All right, so 2 answers here. This one down here is there's no way to represent. No, that's wrong. That's just a mislead. So again, this is one of those practice sets where the questions sort of lead you to the right answer. And the point of that is it's not just some sort of assessment. It's actually helping you sort of try to weave your way through the vocabulary. When plotting a coordinate point like x comma y, which value is dealt with first? We'll just go in alphabetical order, you guys. X comes before y, we're going to deal with the x first. So first we'll deal with x. When plotting 2, 5, which value is addressed first? The 2, because it's in the x position and we deal with x first. All right, so the 2. The first value, the 2 in this case, is addressed first because it is the x value which is the independent value, and then the second value, 5 in this case, is addressed because it is the output or dependent value, right? So we kind of keep saying the same thing over and over in slightly different ways. Given the following graph, what are the domain of values? So what's domain again? Think through it. There's domain and there's range, right? Domain are all the x values. So all we have to do is look at this axis, which is the x-axis, and we have to see where does this thing start. So I can't totally see. Is this here? Yeah. I had to kind of draw this in, right? They kind of made it a little bit loose for us, but that looks exactly right. I'm pretty much parallel. The x values start here at -2. Just think of a number line. And this x value comes all the way to here. What's this? 1, 2, 3, 4. This goes all the way to 4. So the x values are all between here. If you, anywhere you are on here is somewhere that lines up with one of these points in between -2 and 4. So the domain is the set of x values which go from -2 to 4. In set notation, -2, 4. So just keep in mind set notation is where we use a bracket to include the number, because this is actually on the -2 and it actually makes it to the 4. So we use a bracket, -2, 4. It's this answer here. And this is an easy one. All they have here is range, right? So they even are leading us down this road to read what it says, follow the graph, and see if you can figure it out. This one is not trying to trick you or give you a bad score or anything like that. It's trying to lead you to the right answers. Given the following graph, what are the range values? So that was the x's we just did. Now the range is the y. So let's go the other direction. Here and here. These are all the values covered by this in the y-axis. Where are they? This is 1, 2, 3, 4, 5, 6, -6, and 1, 2, 3, 4, 5, 6, +6. So in a range, we're talking about, the range is the set of y values which go from -6 to +6. In set notation, -6 and 6, and it's a bracket because it includes both those values. This dot, solid dot, is not open. In fact, that would have been a nice change here. If we had an open dot, it would not include this. Then when you did a set notation, we would have to use the parentheses to show that that value was not included. All right, given the following graph, what are the domain values? Here we go again. So we're looking at the x. Where does this fall? It looks like right here. So this is -1. And this looks like right here. So this is 1, 2, 3. So that goes between -1 and 3. Domain is the set of values between -1 and 3, and set notation -1, 3 with a bracket to include both because they're solid dots. What's the range? So now we're looking at y. So this starts up here and goes all the way to here. Everything between these two is the range because this is a graph. So this is 1, 2, 3, 4, 5, 6. So this is +6 also. This 1, 2, 3, 4, 5, 6, -6 also. Same answer, but different graph than the one we just did. So maybe just illustrating, hey, you can have the same answer, but a different graph, and that's just the range, the y values. All right, let's go again. Given the following table, what's the domain? So the domain are all the x values. Now in this case in a table, it's a little bit interesting because it's a 5, a 6, a 7, and an 8. Notice that in the graph, we know that we cover all the values, right, along the x between 2 points. Every value in there is covered because it links with that line. We don't necessarily know that for this. So this is done in the answer is sort of given in a unique way. It says the domain is the set of x values which are 5, 6, 7, and 8. We just name them 5, 6, 7, and 8. In other words, we don't totally know that it's the values between 5 and 6. Probably is, but just to be a little bit careful, we did 5, 6, 7, and 8 to show that's the domain, right? So the domain can also be a list of values because they gave us a table in this case. Right? Do they give us the same table and ask for range? They do. What's the range? That's all the y values. So 15, 18, 21, and 24. 15, 18, 21, and 24. Done. That's the range. Given them following. So this one does go back. Now we're looking for domain. Domain are these. This one does say -2 to 1, and it does give us set notation that shows it's everything in between them two. Right? So let's just go with that assumption on this one and be okay with it. Right? The other options don't work. 2 and 5, no. -2 and 4, no. It's -2 and 1. This and this are the ones listed. Now the range, if they ask us on the next one, it's going to be 2 to 5. Right? Let's see if they ask us that. Sure enough, what's the range on the same table? 2 to 5, 2 to 5, all right? 2 to 5. So that's the range. It's a set of y values. And so just to reiterate, domain are all the x values, range are all the y values. And that's as complicated and as simple as that all at the same time. Please make sure you're matching up the title of this video with the title of the practice set you're doing. This is Algebra 1, Semester 1. It's the 3rd unit called Graphing Linears. And it's the 5th lesson called Domain and Range Practice. It's on CreatorMathcom under the Algebra 1 tab. Hope that helps.